With number 2, we cannot rewrite this in a nice form where we can just do the antiderivative without using u substitution. So we're going to set what's inside the square root equal to u, because generally for u substitution we're looking for a function inside of another function. So the 6 minus 4x cubed is inside the square root. So that means our du is going to be the derivative of this, which would be negative 12x squared, times dx. So we can see that this is going to become our u, and then we need to make sure that everything's in place for our du. We have the x squared and the dx, but we're missing the negative 12, and there's a 9 in here. Well, we don't want the 9 there, so with constants that are multiplied by our function, we can pull those out in front of the integral. So I'm going to pull the 9 out, and I want to multiply the inside by negative 12. To keep things balanced, I'm going to multiply the outside by negative 112. Now we have all the parts inside here that become du. And with this 9 out in front, we get negative 3/4 times the antiderivative of all of this is du. I'm going to put that at the end. So that leaves nothing on top, but not exactly nothing. We're going to leave a 1 on top, all over square root of u. But we can think of that as u to the negative 1/2 power. Now that's in one of those formats, just a variable to an exponent. We can easily take the antiderivative of that. Add 1 to the exponent, so we get u to the 1/2. And then multiply by the reciprocal of this new exponent. So multiply by 2, we're going to get negative 6/4 or negative 3/2 times u to the 1/2 plus c. Remember, with indefinite integrals, we need to remember our plus c. And our final answer needs to be back in terms of x, so I'm going to substitute in what u is equal to in terms of x. So we get negative 3/2 times 6 minus 4x cubed to the 1/2 plus c. You can leave it like this if you want, or since this is raised to the 1/2 power, we can write it as negative 3/2 times the square root of 6 minus 4x cubed plus c. Either way is fine.